Hi grade 10s and welcome to this video. In this video, we are going to be working on the mathematics paper 2, and this is a common test from June 2024, specifically from KZN. So this is 50 marks and the time allocated is 1 hour. So let's move on to the first question where we have a diagram. So the first question says, in the diagram, R, which is 5 and 3, W, which is -3 and 0, T, 6 and 6, and K, A and B are vertices of a quadrilateral. Okay, so this quadrilateral RWTK, but they don't tell us that it is a specific type of chord like a rectangle or parallelogram. They don't say anything like that. We just know it's a quadrilateral. Okay, so the first question is to determine the coordinates of M, which is the midpoint of line RT. So you can see if you connect R to T, that's the line we get, and they want us to find the midpoint of this. So to find this, we're simply going to use the midpoint formula. Okay, so the midpoint of that line is found by saying x1 plus x2 over 2, and then y1 plus y2 over 2. Okay, now let's go ahead and substitute. So the points that we are substituting, because we're trying to find the midpoint of line RT, we're going to substitute R and T. So this can be our x1, and that's our y1, and so that's our x2 and our y2. Okay, so let's go ahead and just put them together. So M is going to be found by saying -5 plus 6 over 2 and 3 plus 6 again over 2, since that is 6 and 6. Okay, let's just go ahead and simplify this. Therefore, this means that M is, if you say -5 plus 6, is the same thing as saying +6 minus 5, which is 1. Okay, so that's 1 over 2, and then that gives us 9 over 2. So 9 over 2. Okay, so that is our answer. M is 1 over 2 and 9 over 2. Moving on to the next question. The next question, 1.2, asks us to calculate the gradient of line WT. Okay, so looking at WT, the gradient of that line, we already have the point. So all we have to do is just find that gradient. Okay, so the formula for gradient, you just have to remember that gradient formula is the change in y, so y2 minus y1 over the change in x. So that's x2 minus x1. And now we can just name our points. Okay, so I'll just go ahead and call that, leave it as x2 and y2, and then we'll just leave this as x1 and y1. Okay, so we are saying y2 minus y1. So that's going to be the 6 minus the 0. So we got 6 minus 0. And then over, we have there 6 again minus -3. But remember what happens when you do that. If you say 6 minus -3, this will multiply in and become a positive. Okay, so what we actually have is 6 over 9. That's our gradient of that line. And of course, that can be simplified. There's a common factor of 3, so you just divide by 3 on the top and bottom. So the gradient of line WT is finally just going to be 2 over 3. And that is our answer. Okay, moving on to the next question. The next question, 1.3, says prove that RW is perpendicular to WT. Okay, so that line we just worked with, and we just found its gradient. So we need to prove that RW is perpendicular to WT. What do you know about perpendicular lines? If two lines are said to be perpendicular, then it means that if you find their gradients, the gradient of this line and the gradient of this line, and you multiply those gradients together, they are going to give you -1. Okay, so the good thing is we already have the gradient of this line, WT. We just have to find the gradient of this line. Okay, so we can go ahead and do that. Okay, so since we just need to find that gradient, I'm going to just change one of it. So I'll call this one x2 and y2. Okay, so again, using the gradient formula, I'm not really going to write the formula of it because it is already there. So we'll just find the gradient first of this line, W, R, W. And we're going to say y2 minus y1 over x2 minus x1. So that's going to be 3 minus 0 over negative 5 minus negative 3. Okay, so 3 minus 0 over negative 5 minus negative 3. Of course, that multiplies and becomes a positive 3. So that gives us 3 over, and that's going to give us negative 2. Okay, so we know this is negative. Okay, you can just put it in the middle. So the fraction is negative. Negative 3 over 2. And we already have the other line that we had to look at. We already have the gradient of this line. Okay, we found that to be 2 over 3. So let's go ahead and test whether it's actually perpendicular or not to prove to them. So we're going to take the gradient of line RW and multiply it to the gradient of the line WT. And if it gives us negative 1, then it is perpendicular. So what is negative 3 over 2 multiplied by that gradient, which was 2 over 3, like we saw there, okay? When you multiply these together, do you see that they're all just going to cancel diagonally? The 3 and 3 cancels, the 2 and 2 cancels, and you're left with a placeholder of negative 1 here and a placeholder of 1 here. So that gives you negative 1. Negative 1 times 1 is negative 1. So that would conclude that RW is indeed perpendicular to WT. And there we go. We have proven that. Moving on to the next question. The next question 1.4 says, if RWTK is a parallelogram, okay, we have to determine the values of A and B. Let's go ahead and see what they are speaking about. So this shape RWTK, if it is a parallelogram, we have to use that information to find the values of A and B. Okay, so here's the thing about a parallelogram. There are various ways to prove that a shape is a parallelogram. One of the ways that we can prove this, okay, and the way that they're clearly hinting at here, is about the diagonals of a parallelogram. You see, we already have one diagonal, RT. If you connect W and K, we have another diagonal, WK. The thing about a parallelogram, to prove that a shape is a parallelogram, one of the ways we can do this is to prove that the diagonals bisect each other. Okay, so what does that mean? For the diagonals to bisect each other, it means that this diagonal runs through and then it cuts this one into 2 equal parts. And then this diagonal runs through as well and also cuts this diagonal into 2 equal parts. So this means that this line, okay, it runs and it cuts this line into 2 equal parts. And we see that. So that makes this the midpoint of that line RT. And we already found that. We already found out what M was, that midpoint of RT. But that would also mean that this point is also the midpoint of the line KW as well. So it means they're really just sharing a midpoint. So how can we actually use that information to find A and B? Well, we already found the midpoint. Okay, they told us to find the midpoint in the first question, which was 1 over 2 and 9 over 2. Okay, 1 over 2 and 9 over 2. Since we have this midpoint, we can now use this information because we know that it is the midpoint of this line KW. We can now use it to find A and B. Okay, so here's how we're going to do this. Because we have the midpoint, we are going to use the midpoint formula. So we can take that as x1 and y1 and go ahead and take this as x2 and y2. Okay, but we are saying that we already have the midpoint. Okay, so we are going to go ahead and use the midpoint formula. We're saying that the midpoint of that line KW is found by saying x1 plus x2 over 2 and y1 plus y2 over 2, and then we're going to substitute. So with x1 and x2, we're putting in exactly what they are. We're speaking about the midpoint of the line KW. Okay, so we're going to have to use their endpoints. So that is the negative 3 plus a over 2 and the 0 plus b over 2. Okay, I actually want the variables to come first. So let's rather leave this as x1 and y1, and then that can go ahead and be x2 and y2. Okay, so we're going to say a plus negative 3 over 2, b plus 0 over 2. That's what we're going to fill in here to find that midpoint. So with a plus negative 3, if you say plus negative 3, you end up with a minus because positive times negative is negative, okay? Minus 3 over 2. And then b plus 0 over 2, and we of course know 0 is just going to be nothing. Now here's the thing. We know what the midpoint of this line is. The midpoint of KW is that point 1 over 2 and 9 over 2. So in place of midpoint of KW, that's what we're going to put there. 1 over 2 and 9 over 2. And this is just how we find it. We make them equal to each other because they really are equal to each other. One part speaks about the actual midpoint of KW, and the other part speaks about the calculation of the midpoint of KW. Okay, so since we make them equal, here's how we can actually solve. This is the x value of this midpoint. This is the calculation for the x value of the midpoint. So we make them equal to each other. So this means that 1 over 2 is equal to a minus 3 over 2. And likewise, this is the y value of the midpoint. This is the calculation for the y value of the midpoint. So we also make them equal. 9 over 2 is equal to b over 2. I'm now going to write b plus 0 because b plus 0 is just b. Okay, so this is what we have, and now we can just solve. So do you see here, the only thing we can just cancel the 2's. It's really just like multiplying by 2 on both sides. You see, if you have equivalent fractions in an equation, you can just cancel the denominators since they are all the same. Okay, and then this means 1 is equal to a minus 3. If you take the negative 3 over, you're going to have it being positive. So it's now a is equal to 1 plus 3 gives you 4. And so that's our value for a. A is equal to 4. And then we can find b. So again, just cancel the 2's or multiply both sides by 2. And that would mean that b is equal to 9. Okay, so there we go. We found a and b. Okay, so they only asked us for those a and b. They didn't really say put it as a coordinate. So we can just leave it like that. Those are our values for a and b. Moving on to the next question. We are now on question 2, and 2.1 says, B, the point x and 5, is a point that lies on the Cartesian plane. If it is given that OB is 13 units and BOX, that angle BOX, is theta, as we can see it measured there. If that is theta, using the diagram without the use of a calculator, determine the value of x. Okay, let's go ahead and find the value of x. So this just has to do with dealing with this triangle that is going to be formed here. You're going to go to the point and drop a line down to the x-axis. And this line is, of course, perpendicular to the x-axis, making a right angle triangle. Okay, so this is x, right? Let's just fill in where these sides should be. This is x. And this is a y value, okay? Because it's a y value, y values we find like this. So they tell us the length, okay, the height really of that triangle. So it means that the height of that triangle is 5. We're going to put 5 over there. And then the x is over here. That's what's missing. And we have to find x. So you see we have a right angle triangle. Only one side is missing. We have to use Pythagoras. So let's go ahead and do that. It is a shorter side, not the hypotenuse, that's missing. So the equation is going to be x squared is equal to the longest side squared, which is 13 squared, minus the other shorter side squared, so minus 5 squared. Okay, and we're just going to have to simplify that. Okay, so x squared is equal to 13 squared is 169 minus 25, which gives us 144. And then we're going to have to solve for x. Since there is a square stopping us from getting to the x, we're going to get rid of it by doing the inverse of squaring, which is to square root. But because this is an equation, you're going to have to include plus or minus because the positive and the negative solution would work for this. Okay, the square root of 144 is 12. So it means that the choices you have are between positive and negative 12. Okay, so really the equation is saying something squared is equal to 144. So it's either positive 12 squared gives us 144, which it does, or negative 12 squared also gives us 144. And that's why we include both. Okay, so now you have to decide whether it's going to be positive or negative. Based on where x is over here on the Cartesian plane, is it going to be positive or negative? It's going to be negative because it's on the negative part of the x-axis. So it means that x is equal to negative 12. So we know that, and you can just decide from here. Negative 12 units. And that is the answer. Moving on to the next question. 2.1.2, very simple. They just want us to find the value of cos theta. So you know from this acronym that you would have learned in trigonometry, SOHCAHTOA. Okay, that cos is found by saying adjacent, the adjacent side over the hypotenuse. So that's what we're going to do here. So here is our reference angle, theta, and we're going to say the side next to this is the negative 12 over the hypotenuse, which is 13. So we can see that cos theta is equal to negative 12 over 13. Okay, moving on to the next question. The next question, 2.1.3, says we need to find 12 sine theta over cos theta. Okay, now I'm looking at this and I'm thinking, I don't know. Do you guys deal with identities? Do you guys know that tan theta is actually equal to sine theta over cos theta? And I'm starting to think that starts in grade 11. So, okay, we can just substitute. So here's how we find this. 12 sine theta over cos theta would simply be found by saying, we're just going to say 12 and then find out what sine theta is. From SOHCAHTOA, sine is found by saying opposite over hypotenuse. Okay, so we'll just take the opposite side over the hypotenuse in our triangle. The opposite side, opposite that angle, would be 5 over the hypotenuse, which is 13. Okay, so that's what we have there. But remember, they're standing next to each other, so they're really just being multiplied. So we're going to have a 5 over 13 all over cos theta, which we already know is negative 12 over 13. So divided by negative 12 over 13. Here's how you can just make this simpler for yourself. So these two are going to work together first. And instead of saying divided by, you can just use a division sign. Divided by negative 12 over 13. And then let's just go ahead and work on simplifying without a calculator. Okay, so 12 is a whole number here. To make it a fraction, you can put it over 1. So when you're multiplying fractions, you multiply numerator with numerator. So 12 times 5 is 60 over denominators multiply 13. And here's one thing, we have a division here. When you're dividing by a fraction, you can use this rule called tip and times. So we tip the fraction, we swap the numerator and denominator, making this 13 over 12. And then you change the division to a multiplication. Okay, so that's what we have. And now we can go ahead and simplify this. So look at how you can simplify. Instead of multiplying and then thinking about how you're going to divide it because of the common factors, you can first of all focus on cancelling out any common factors. Do you see that 13 and 13 are common diagonally? So they will cancel, which now you're going to have 60 and might as well just put them over each other. So it's 60 times the placeholder of 1 there, stays 60, placeholder of 1 here times 12, which is 12. Okay, and I shouldn't forget that negative. It's negative still. Okay, so this is also still negative. Okay, so you see here we have negative 60 divided by 12. You saw how we said 5 times 12 or 12 times 5 gave us 60. So 60 divided by 12 gives you 5. So this is negative 5, and that's our answer. Okay, moving on to the next question. Okay, the next question, 2.2, says, given that x is equal to 20 degrees and y is equal to 21 degrees, calculate the value of the following correct to 2 decimal places. So there's no overthinking here. We're going to use the calculator. Okay, so we have cos 2y, and they told us what y is. Y is 21 degrees. So just say cos 2 times 21 degrees, which gives you 42 degrees. So this is cos of 42 degrees that you have to just substitute into your calculator and round off to 2 decimal places. So that's cos of 42 degrees. And that gives us, as you can see, 0 point. And then if you round off to 2 decimal places, you see the 3 is less than 5, so it falls away. So 0.74. And that's our answer. Moving on to the next question. Okay, I'm just putting them together because you see these ones are just substitution. So with 2.2.2, you have sine of x plus y. So in place of x and y, just substitute the values that they are. So this is sine of 20 degrees plus 21 degrees, which gives you 41 degrees, okay, because those are the values of x and y. So what is sine 41 degrees on your calculator? Sine 41 degrees is just going to give you, and just round off to 2 decimal places. So that is going to be 0 point. Now, do you see we have 656? 6 is greater than 5, okay? So it's going to round up and add a 1 to that 5, making that 6, 6. And there we go. Okay, and the next one, we're just going to put it there. So they want you to find sec of x. Okay, so secant x. Now, that's, remember that it stands for 1 over cos. Okay, 1 over cos x. So we're just going to say 1 over cos, and x is 20 degrees. So what is 1 over cos 20 degrees? We'll say 1 over cos of 20, and that gives us 1 point. Remember, we have to round those 2 decimal places. So 1.0, then we have 64. The 4 is going to round down, so it doesn't round up. So you're just going to have 1.06. So that's our answer there, 1.06. And that is it. Remember, these are not in degrees, okay? These are just the values. They're not in degrees. Okay, so that is it for question 2. And then we move on to question 3. Okay, question 3 and 3.1 says, without the use of a calculator, calculate the value of, and we have to calculate the value of this. Okay, so let's go ahead and just start. You see that they're using special angles here. So, grade 10s, you need to have your diagram for special angles, or you could use the circle, your triangles, whichever method that you're comfortable with. But I'm also just going to introduce a method that you can use here. Okay, so this is called the OHA rule. So it's for special angles. So we say OHA for opposite, hypotenuse, and adjacent. And then the angles, we're going to list them down. It's 30 degrees, 60 degrees, and then 45 degrees. Okay, in that order, remember. It's a smaller one, bigger, and then another smaller one. Okay, and then we say 1, 2, 3. And then in the next row, 3, 2, 1. And the last row, 1, 2, 1. Then in each row, amongst the numbers, you're going to square root the biggest number. In this row, it would be the 3, so we square root the 3. In this row, it would be this 3, again, square root that. And in this row, it would be the 2, so we square root that. And this is going to help us to find all the values of our functions when they have special angles. Okay, so let's go ahead and work on this. We have sine squared 45 degrees. So to find sine, okay, remember what sine is? What over what? From SOHCAHTOA, so you're going to always use this along with the OHA. You can use it like that. From SOHCAHTOA, we know it's opposite over hypotenuse. So that's going to be the opposite over the hypotenuse. And we're going to go to 45 degrees. So the 45 degrees row is here. And because we're looking for sine, we'll go opposite over hypotenuse. You see that is 1 over square root 2. So we'll say 1 over the square root of 2. Let's just put them big. It's fine. Okay. And you see that that is still being squared. So square it at the end. Okay. Then minus cos 60. Minus cos 60. How do we find that? In the OHA rule, we go to 60 degrees. Go to the 60 degrees row. And we know that cos from SOHCAHTOA is adjacent over hypotenuse. So we're going to go the adjacent A over hypotenuse over 2. So it's 1 over 2. So that is minus 1 over 2. And then over here, we have something very interesting going on here. 10 degrees is not a special angle. But not to worry, because do you see that they put tan 10 degrees, but they also put cotan 10 degrees. Okay, well, you know that tan 10 degrees is just, it's just tan 10 degrees. And these two are next to each other. So what are they actually doing? They are multiplying. So what is cotangent equal to? It is 1 over tan. So look at what happens there. You're multiplying it by 1 over tan 10 degrees. Okay, let me just move that more. Okay, that's away now. So this is what's going to happen. Remember, when you have two things multiplying, and on the numerator, because this tan 10 degrees is on the numerator, its denominator is just a natural number of 1, okay, since it was not a fraction. So what happens is when you are multiplying, you can cancel anything that is common across. So these two would cancel. You don't have to cancel the ones because 1 is really just 1. It can be the placeholder, it's fine. Okay, so that solves the problem. That's gone. Let's go ahead and simplify here. So this is squared. Square everything inside the bracket. So 1 gets squared and it's 1. Square root of 2 gets squared and it becomes 2 because it breaks open that square root since they are the inverse of each other. Then you still have minus a half plus what is left here. Okay, you have to see them for what they are. Originally, you had how many terms? You had, let's count. Terms are separated by plus and minus signs. So here's a minus sign, here's a plus sign. It means this is a term on its own, this is a term on its own, and that is a term on its own. So you have 3 terms. So this is still here. There's still a term here. What's left here? Tan 10 degrees and tan 10 degrees cancelled. So you're left with 1 because this is a placeholder of 1 over 1 times 1 over 1, which is just 1. So 1 is left over there. Okay, so what happens here is you have a half minus a half, which is nothing, and then plus 1, which is 1. And so that is our answer. The answer to all of that is just 1. Okay, moving on to the next question. Okay, the next question says solve for x correct to 1 decimal place. Okay, where x is greater than or equal to 0 degrees, but less than or equal to 90 degrees if this is our equation that we have. So we just have to solve for x in this equation. 1 over 3 sine x is equal to 2. And you see what they give us on your Cartesian plane. This would lie between 0 degrees and 90 degrees. So you don't have to overthink anything about which quadrant does it lie. It's just in the first quadrant. So we'll take whatever value gives us like that. Okay, so this is equal to, and let's just go ahead and simplify. Okay, you can cross multiply, or we can just say, let's multiply both hand sides by 3 sine x. Okay, so if you multiply by 3 sine x to get it out of the denominator, this is what happens. Over here, it will cancel with that 3 sine x, and you have 1 here is equal to, and now you have 6 sine x. Okay, then you need to get sine x on its own because you're trying to solve for x. So you first have to solve for sine x. You have to get sine x on its own. So how can you do that? You can do that by removing the 6. So the 6 is multiplying to the sine x. So you need to divide both hand sides by 6. And let me just rewrite them like this. So this, the 6 here cancels and you're left with sine x is equal to, and here that is 1 over 6. And you just have to find x in this equation. So you find x by saying, and I'm just going to leave it as x because you know it's in the first quadrant. We do not have to really consider, where it's repeating or anything like that. And this is grade 10. Don't think you guys work on that yet. Okay, so x is equal to, and to solve for x, you're really trying to get rid of the sign. Okay, the only way to get rid of it is to do the inverse of sine. So in actual fact, what we're doing is the inverse of sine on your calculator would be found by pressing the shift button and then sine. That's the second function of sine. Okay, but how I would like to see it is we take it over, okay, and then it becomes the inverse, which is shift sine, and then we have 1 over 6. So you find that, you actually find your answer. So shift sine of 1 over 6, just say 1 over 6. Okay, 9.59. But remember they say round off to 1 decimal place. So that is going to be 9.6. Okay, because the 9 is going to round up. So 9.6. And this is an angle, so degrees. And that is our answer for x. Okay, so that is it for number 3, question 3, and we move on to question 4. Okay, question 4. 4.1 says, use the diagram below to prove that the opposite sides of a parallelogram are equal. Okay, the opposite sides. So we're really just trying to prove that this side is equal to this side and this side is equal to that side. Okay, so we can actually write them down. We are required to prove, I'll just say RTP. We're required to prove that MR is equal to CX and MC is equal to RX. That's our goal. Okay, how can we do that using what they have given us? Well, we have parallel lines. And what kind of angles can we find on parallel lines? We can find fun angles. Okay, so corresponding, co-interior, and alternate angles. That's what we can find on parallel lines. And that's what we're going to do. So the best way to actually prove that these are equal, prove that this is equal to this, and to prove that that is equal to that, is by looking at these sides as part of the triangles they are a part of. Okay, so these two sides are part of this triangle over here, this triangle CRX, that triangle. And these two sides are part of this triangle RCM, this triangle. Okay, and what we can just show is that these two triangles are exactly the same. In other words, we're going to prove that these two triangles are congruent. And if we can prove that, it would mean that all the corresponding sides must be equal. So let's go ahead and do that. We can name our triangles first. So we'll say in triangle. It's important to name it properly, but okay. So in triangle. So this one, we can start by naming it from here. So we're saying RMC, okay? RMC. Now the other one needs to correspond. And here's how we can look at it. You're going from R, right, to M, the yellow part, to the purple part. So when naming this one, you need to go from C, okay? So you see that was the kind of like where the, I say acute angle. Okay, we went from R, the highest point. So you need to go from C down to X, okay, we're by the yellow line, and then to R. So we're going to call that one CXR. And if you name it properly, it becomes very easy to just prove because you can follow the naming. Okay, so let's find out the things that are equal in this triangle. We need 3 things to be equal, okay? Or we need to have one of the cases of congruency. Let's see. So we have fun angles. Let's stick with using fun angles in these triangles. So because we have fun angles, do you see that if you draw alternate angles here, which is really what we're going to use throughout, alternate angles, okay, because of the Z and the ends it creates, you can see that angle R1 is going to be equal to angle C2. So we can tell them that. Tell them that angle R1 in this triangle is equal to angle C2 in the other triangle, okay? And why are they equal? They're equal because we have alternate angles on parallel lines, and you can just tell them the lines that are parallel. So this is really just for grade 11 and 12. It helps you if you work with it like that. Okay, naming the lines that are parallel. So tell them this is because MR is parallel to CX. See, those two lines are parallel. Okay, so that's the first one that we have. The second thing that we have here is we can also draw alternate angles another way as well. So we can draw alternate angles like this. We can draw it like an N, okay, a weird looking N, but there we go. We also have alternate angles over there. And this would mean that this angle C1 is equal to the angle R2. Okay, so we tell them that R2 is equal to angle C1. Okay, same reason. It's because we have alternate angles and we can tell them the lines that are parallel. The lines that create those alternate angles are the lines, the parallel lines, RX and MC. Okay, so because MC is parallel to RX. Okay. The third thing that we have being equal in these two triangles, those can you see, because this is the triangle here, that is that triangle here, do you see that they are sharing this side CR? They have a common side. So because of that, we can tell them that CR is equal to CR, which is just a common side. Okay, it's the side that is equal. And now we have three things. So this proves that triangle RMC is indeed congruent to triangle CXR. And the reason they are congruent is because you see you have two angles and one side being equal. So you can say side, angle, angle, or angle, angle, side. It's fine. Okay, so I'm going to say angle, angle, side, because I mean, that's the order in which I found it. So because they are congruent, it means all the other corresponding sides and angles of these two triangles are equal. So that would conclude now that these two will be equal as well. Because you see this blue triangle, if you picked it up and you flipped it over so that this line RX lies perfectly with this, you will see that these two triangles are really just the same triangles. This is just positioned like that, and that is just positioned like that. So that therefore proves that MR is indeed equal to CX and MC is equal to RX. Okay, because we have congruent triangles. And that is our answer. And we can just end off like that. We have told them everything, the two sides that they said should be equal. They said the opposite sides. Okay, so therefore the opposite sides are equal in the parallelogram. Okay, that is it for question 4.1. Moving on to question 4.2. Okay, question 4.2 says, in the diagram below, ABCD is a parallelogram, okay, with angle A being equal to 5x plus 5 degrees. So just keep that in mind. And we can just write that down. Remember, that is 5x plus 5 degrees over there. And this angle C is equal to 8x minus 16 degrees. Okay, first question is to calculate the value of x. Sorry, it's a bit cropped out there. Okay, let's find the value of x. Using what we know about parallelograms. Okay, we have a parallelogram. They gave us the angles of this parallelogram. They gave us the opposite angles. What do you know about the opposite angles of a parallelogram? They are equal. Okay, so what we can do is say that angle A, we know that angle A should be equal to angle C, since this shape is a parallelogram. Therefore, that would mean that 5x plus 5 degrees is therefore equal to 8x minus 16 degrees. Okay, so that's because opposite angles of a parallelogram are equal. And we can go ahead and just solve for x. Okay, so you can take the 5x over. If you say 8x minus 5x is equal to, and then you still have 5 degrees here, and take that over, and it becomes positive 16 degrees. Okay, so now when you add those together, they give you 21 degrees, and that gives you 3. So this is 3x is equal to 21 degrees, and then divide both sides by 3 to solve for x. Therefore, x is equal to 7 degrees. And that's the value of x. Okay, moving on to 4.2.2. The next question is determine the size of angle B. Okay, angle B is this side over here. Okay, you know how these two, we know that the opposite angles in the parallelogram are equal. So it would mean that angle B is also equal to angle D. Okay, this is going to help us a lot. We already know what x is, so it means that we can actually find the size of these angles. You just need to substitute one, really. Okay, so we can find the size of angle A by substituting the value of x in here. So angle A is going to be, we're going to find that first, so it will help us to find angle B. So here we go. Angle A is equal to 5x, but we know what x is now. It's 7 degrees. Okay, plus, and that was 5x plus 5 degrees. Okay, plus 5 degrees. And 5 times 7 is 35, plus 5 is 40. So angle A is equal to 40 degrees. Okay, here's why this is going to help us. If we know that this is 40 degrees, then this is also 40 degrees. How would we use it to find angle B that they asked us to find? We know these two are equal, and what we also know about a parallelogram, or really any quadrilateral, is that if you add up all the angles in a quadrilateral or parallelogram even, they add up to 360 degrees. Okay, so here's how we can actually form this. We want to find angle B, but we know that these two are equal. So instead of calling this angle D, why don't we also just call it angle B, since they're the same thing? So I'm stating first that I know that angle B is equal to angle D. And this is, of course, because of opposite angles in a parallelogram. Now, because I've called it that, here is how we're going to sum up the angles in this parallelogram. So we're saying that we'll take the 40 degrees, add that with the other 40 degrees in this parallelogram, and we added with angle B and angle D, but in place of angle D, you don't have to say angle D, you can just say angle B again, since they are equal. Okay, whatever angle B is, angle D will also be. So look at that, this equation, and then you're going to say that it adds up to 360 degrees. This equation helps to solve for angle B, since it's going to be the only variable that we have. So that's what we'll do. Okay, and the reason for this is because the sum of the angles inside a parallelogram, or even a quadrilateral, really, it's because it's a quad, they add up to 360 degrees. So it's the sum of angles in a quad. So this is going to be, add them together, they'll give you 80 degrees. Angle B plus angle B gives you 2 angle B is equal to 360 degrees. And then we can solve for 2 angle B by taking 80 degrees over. So what's 360 degrees minus 80 degrees? That's going to be 360 minus 80 gives you 280 degrees. Okay, so 280 degrees. And then to solve for B, you can go ahead and just divide both hand sides by 2. And therefore, angle B is equal to 140 degrees. And that's our answer. And that, of course, means that angle D is also equal to 140 degrees. Okay, so that is it for question 4. And we move on to question 5. Okay, question 5.1 says, in the diagram, angle B is equal to 30 degrees, as we can see over there. VRS is equal to 100 degrees. And they want us to determine with reasons the size of the following angles. The first angle they asked for is angle V1. Okay, how can we find angle V1 given what we have? Do you see that we have included with angle V1, we have a triangle, okay? And this triangle has an exterior angle. See, if it's an extension of the one of the sides of that triangle, then that is an exterior angle. And what do you know about the exterior angle of a triangle? It is going to be equal to the sum of the two opposite interior angles. So that means that to find angle V1 plus 30 degrees gives you 100 degrees. Okay. And of course, our reason would be exterior angle of a triangle. Then we can just solve for angle V1. This is equal to, if you say 100 minus 30 degrees, because that comes over, you get 70 degrees. And that is our answer. Angle V1 is equal to 70 degrees. Okay, moving on to the next question. The next question, and we should probably just put this down because it will be helpful probably. Okay, so that's 70 degrees now. The next question is 5.1.2 says angle S1. So find angle S1 if VR is equal to RS. So where are those? VR, this line, is equal to RS. Okay, so do you see that we have an isosceles triangle over here? Okay, so the goal is to find angle S1 if these two lines are equal. Okay, if these two lines are equal, how do we find angle S1? Well, we can see that angle S1 would be equal to angle V2. Okay, since these two lines are equal, the angles opposite those equal sides will also be equal if you have two equal sides. And we have 100 degrees. So we know that all of them should add up to 180 degrees, but these ones are exactly the same. So instead of calling this angle V2, because they are equal, we'll just call them angle S1. Here's what I mean. So we're going to add up these together, but first we will tell them that angle S1 is equal to angle V2. So here's the thing, because these two lines are equal, that therefore means angle S1 is equal to angle V2. And the reason is because we have angles opposite equal sides, not because it's an isosceles triangle. Well, it is, but it's because the angles opposite equal sides in a triangle will be equal. So now that we know these two are equal, we can do this. So we're going to use the sum of interior angles in a triangle. So if you say angle V2 plus 100 plus S1, they give you 180 degrees. But since these two are equal, instead of saying angle V2, just call it angle S1. So we're saying angle S1, and we would have said angle V2, but because it's equal to S1, we also just call it S1, plus 100 degrees equals 180 degrees. Very similar to what we did in the previous question. Okay, so that's what we're going to put over there. And this is because of the sum of angles in a triangle. So this, when you add them together, they give you 2 angle S1 plus 100 degrees is equal to 180 degrees. And then 2 angle S1 will take the 100 degrees over. It's 180 degrees now minus 100 degrees, which gives you 80 degrees. And if you divide both hand sides by 2 to get rid of that 2, angle S1 is therefore equal to 40 degrees. And there we go. Okay, so we found angle S1. Moving on to the next question. And now we're on 5.2, and 5.2 says, in the diagram below, PQRS is a rectangle with E, okay, being the point of intersection between the diagonals of the diagonals, okay. And then they tell us that QSR is T, equals to T, okay. The question is to calculate the size of angle E4 in terms of T, okay. So find angle E4 and it should relate to T. Okay, looking at those angles, E4 and T, how are they related? Well, they already told you that the diagonals here bisect each other, right? Kind of told us that by telling us that this is the midpoint. So because of that, we would know that, remember, in a rectangle, the diagonals of a rectangle are equal. Okay, it's not it's not like in a parallelogram. So this would now be equal to this, okay, and this is equal to this, and all of these little lengths, they're all the same. So it means that over here you have an isosceles triangle. So what would that mean in this isosceles triangle? It means that this angle T is equal to this angle R2. Okay, so because those two are equal, we can just call them T. So T and T. Now, how can we use that to relate it to angle E4? Here's the thing. You have lines going across here. That's vertically opposite angles. So these two are equal. So we're going to focus on finding angle E2, and that will find angle E4. And this will be fine because angle E2 is part of this triangle where we have T. So let's focus on finding angle E2 given what we have. So we know these two lines are equal. We'll tell them that, of course, and then tell them that these two angles would now be equal because of that, because we have angles opposite equal sides being equal. Okay, so let's just go ahead and start with that. So we'll state the lines that are equal. ES is equal to ER first of all. So ES equals ER. And that is ultimately because we know that the diagonals of a rectangle are equal. See, those two are exactly the same. So if this is now the midpoint, and you know, those little ones would be the same and those little ones would be the same, making every little side like that equal. Okay, so it's because of the diagonals of a rectangle being equal. And now that those two sides are equal, we can tell them the two angles that are equal. So these are equal, therefore these two angles are equal. So we can say angle R2 is equal to T as well. So angle R2 equals T. And this is because we have angles always going to be equal if they lie across equal sides in a triangle. So angles opposite equal sides are equal. Okay, so now that we have that, this is T, that is T, we're just going to focus on finding angle E2. So to find angle E2, this is a triangle. So we can use the sum of angles in a triangle. So we're saying angle E2 plus T, okay? And they're going to add up to 180 degrees because they lie in a triangle. So angle E2 plus T equals 180 degrees. And this is because of the sum of angles in a triangle. And now this is going to be E2 plus 2T being equal to 180 degrees. But you really just have to make this the subject. Remember, if you find E2, you find E4. So let's make that the subject by saying this is equal to. We add those two together, they give you 2T, but then you take that 2T over. So that is 180 degrees that is still here minus 2T. And we know now that these two are right opposite each other, so they will be equal. They are vertically opposite angles. So we tell them angle E4 is equal to angle E2 because they are vertically opposite. So vertically opposite angles are equal. Therefore, that means that angle E4 is finally equal to 180 degrees minus 2T. And that is our answer. That is how to express angle E4 in terms of T. Okay, so that is it for this video, grade 10s. I wish you guys all the best for your June exams, and I hope to see you guys in the future videos. Bye.